So hello friends, welcome back to my YouTube channel. I'm Ismail. In this video, we are going to discuss about theorems of integrable function. So what are the theorems we'll discuss? So first of all, we should have an idea about that what are the positive and negative part of the function. So basically a function can be written as f is equals to what? F plus minus f minus. Okay, so the positive part of the function is defined as the maximum of basically f and 0, and the negative part is what? The minimum or the minus of minimum of f and 0. It is basically written as f is equals to f plus minus f, and we can just define that mod of f is what? F plus f minus. Okay, and one more result is for this is basically the integration over e of f is what equals to the integration over f plus over e minus of integration over f minus over e. So these are three to four results that we will we should have an idea. Yeah, so by for proving this theorem, so we'll use these types of result. Okay, what is the theorem? If f and g are two measurable function over e, then the function f plus g is also measurable, or sorry, also integrable. Yeah, not measurable. Yeah, it is integrable. So if these both are integrable function, then f plus g is also integrable, and the integration can be written in this form. Okay, and if f is less than g, then f is less than g almost everywhere. Then f the integration over e of f is also less than the integration over z, and a and b are disjoint measurable set, then it can be written in such a way. So we'll just use this concept. So basically, yeah, if these f is said to be a measurable function, then we can write in this form. Okay, yeah, this is the concept. Now if it is a measurable function, then it is an integrable function. Okay, this is the sufficient, sorry, necessary condition for that. So we'll prove just first result. So what is the first result says that we'll prove just f plus g is integrable, and then prove that f integration is also the integration yeah, this can be written in this form. So basically, since f and g both are integrable function, then f plus g plus f minus and g minus are also integrable. This is the result. If f is integrable, then we can conclude by this result these all are also integrable. Okay, then we'll have h. We'll just define h is equals to f plus g is what? F plus minus f minus plus g plus minus g minus. So it is what? F plus g plus, and what? F minus is what? F minus plus g minus. So it is what? So I can just conclude that this is my positive part, so I can just define it as h plus minus of h minus. It means my h is also integrable function. So that what is h? H is what? H is equals to f plus g is what? Integrable function. So that's why we can say that f plus g is also integrable function. Now we'll just show that f plus g can be written as the integration of f and integration of g. Okay, so if h is integrable over e, then I can just write f plus g is integrable over e. It means we can just write as f plus g plus. What is this? This is by separating, it will be in such a way minus of f minus plus g minus. Okay, so we can write in such a way. Wait, so this in bracket will be here. So we'll just write f plus in the bracket plus g plus minus of f minus plus g minus. Yeah. So we can just integrate by part because these all are integrable. So that it is what? F plus integration over g plus minus of integration over, yeah, over e, integration over e of f minus minus of integration over g of g minus. Now we'll just write as it is what? F plus minus of e over f minus. Okay, This is one of the result, and second one is E of g plus and integration of g minus over e. So this is the result that we have already discussed. This is what it is, nothing but integration of f over e plus integration of g over f. This is what the integration of f plus g. So we can just prove easily this is the result. Okay. Now we'll go to the second result. Second result is saying that if f is less than, the second result is saying that f is less than equals to g, then the integration of f is also less than equals to g. The same concept is here. We'll just have f is less than equals to g. It means what? F minus is what? Less than of g plus minus g minus. We'll just integrate these both. Okay, we'll just integrate because these are both are integrable function by the previous result. Okay, minus. So we can just separate it. How can we separate? If we will separate it, so f plus over e minus of f minus over e, which is less than equals to the g plus over e minus of integration of g minus, and these both are after integrating. It is what the integration. Okay, it is basically the integration of f over e, and this is what the integration of g over e. This is the result basically. So it is proved and proved. Now the third result is what? If a intersection b is phi, means these both are disjoint miserable set or disjoint miserable. Okay, disjoint miserable set, then we can just write f as yeah, f as integration of f as that can be write in such a way. Okay, with on the different set or over the different sets. Okay, so if f is integrable, then by the characteristic of the function, it is what? F into the characteristic over the a union b. Okay, if it is a union, this is what the characteristic of function. It is just defined as the characteristic of function over any set E is defined as 1 whenever x belonging from E, 0 whenever x does not belongs to E. Okay, so it is just written in such a way that it is what? F and the chi of A plus chi of B. So it can be distributed over these both. So it is what? The integration over A. Okay, the integration A union. Is there union? Yes. So it is not. Yeah, it is disjoint. Then this is what? A union B. Yeah. So it is over A union B. Oh, yeah. A union B can be written in this form. Okay. Or even whenever we are writing in this way, the previous video we have already discussed. So we can just write it is what? E and chi of E of dx. This is the property. Okay. So if it is over A union B, then it is what we will multiply just the characteristic of function of A union B. This characteristic of function can be written in such a way that, and if we write these both, if it is distributed over these both, then this will be what? Integration over f, sorry, integration over A of f and integration over B of f. This is what? A union B whenever these both are, yeah, whenever these A union B is what? Disjoint set. Okay, this is the result. So all three results we have proved. Next result is basically if f is a measurable function over E, then f is integrable over E if and only if mod of f is integrable over E, moreover if f is integrable over E. Okay, yeah, we'll just prove. So we'll show this. So how can we do the proof for this is when let f be a measurable function. If f is a measurable function over E, if f is integrable, sorry, f is integrable, then measurable and integrable, then both the part f plus and f minus are integrable. So mod of f is written as f plus plus f minus. So the mod of f is also integrable because f plus and f minus both are integrable function. So we can just write in such a way that, yes, we can just write in such a way that f of x is less than equals to the mod of x, okay, and the integration of f of x is less than equals to the integration of mod of x, and again minus of f of x is what, less than equals to the integration of f of x. Obviously if f is less than of mod of fx, then minus of f is also less than this. So what, the minus of f of x is less than equals to the integration of minus of f of x is what, is less than equals to the mod of f of x. And if it is positive part and negative part combinedly, I can just write the mod of f of x, the mod of integration of f of x is what, the less than integration of mod of f of x. So okay, this is the first equation, this is the second equation. One is representing the positive part, negative part, it will combine, this will mod. So this is the result. Okay, and one result is this: if f and g are measurable function and mod of f is less than mod of g and g is integrable, then f is also integrable. Obviously we can just prove it. This is the result: if f mod of f is less than mod of g and g is integrable, then f is also integrable. We can prove it. This is the result. So thanks for watching my video. Keep watching MS Maths. Thank you.